Hi. So today we will see how to set up Gemini Cohere model with LangChain and set up embedding model in-memory vector store, use pydantic models in LangChain for data validation, and we will use our own CSV file, load it, and see how to use it within uh, Pandas and do some data analysis as well. So the task here is we have a sample e-commerce dataset which contains customer emails and it has a products catalog. So the task is to classify these emails into order request and product inquiry. Right here we have a load env where we are loading our environment variables. We have Google API and Cohere API. So using these because you can use them for free. Google has some rate limits, but Cohere works great. And we will be comparing these two models. Here we are setting up Gemini. For example, you can use Gemini with a LangChain using the LangChain Google Gen AI library, and here we are using Gemini 2.5 Flashlight. Then we set up the Cohere model. Similarly, we import it from LangChain Cohere, and here we set up some embeddings. We are using LangChain and Cohere, the Cohere embedding model embed v4. This is the latest embedding model from Cohere. Then we are setting the pydantic models. We are using pydantic for enforcing data validation and structured output. And here we are setting up some AI configuration. We are supporting both Google and Cohere models. So we have fields for both of them, and we are using, by default, we are using the Gemini Flash model. And here we have read input section. What we are doing is we have this email CSV, sample emails that any e-commerce site may get, and we also have this products catalog and their category description, the stock that we currently have in our inventory, and the season and price. We have this function that reads the CSV file and it gives us a data frame, a Pandas data frame. Here we have another function that validates our emails. So we add email validation here. We are saying if there is no subject, because we have deliberately added some areas where we do not provide the subject in the email. So just another layer of validation and security in case there is some missing data. This is how you can use it to skip it out or add whatever checks. Another function that validates the products similar to email, where we get the product ID and name, category, stock, all of these fields, and then we create this product data pydantic model out of this data frame, and we load it and then we return it. And here we are just printing the amount of data that we have. Here we can see the categories the products can have. There are 34 products in the accessories category, men's accessories, bags, and these are all the different kind of categories that our products can be. And this is an example of the emails that we may have. And here we are printing the first three products just to get an overview of the data, and then we create. So now coming to the important part, here we have the LangChain, pydantic, and the AI models integration. So we import typing and we get the tuple and union from typing, and we have Pydantic output parser, also a good option if you want to enforce structured output from the LLMs. This is the main class that is going to be doing all the major work. Before this, we have the email classifier. Here we are saying we can accept either Cohere chat or chat Google generative AI. This is from the LangChain to access the Google model, and this is for the Cohere model. And here we pass the AI configs. So let me just remove this, and here we are initializing the LLM that we get, can be either Cohere or Google. Then we set the configs, and this is where we are asking the LLM to give us a structured output. We add LLM with structured output, and this is the email classification. This is the one we have. This can have category, and it can be a confidence. So this is the structured response for email classification with confidence, and the category we are asking the LLM the classification category for the email and the confidence score for the classification. Once we have this, we then move on to, if this fails, we are asking our class to use the Pydantic output parser as a backup option, and we are tracking which one are we using. Are we using the LangChain with structured output? Are we using the Pydantic output parser? Based on that, we are then checking. We are providing the template prompt here that says you are an expert email classifier for fashion store, and you have to classify these into either product inquiry or order request. So these are the only two possible options that you have. Then we create chain. So this is the classification chain. This takes the prompt and the structured LLM that we just created, and this is in case we are using the structured output from LangChain. And if we are using the Pydantic output parser, then we will use this setup. So here we are providing the prompt, and then we create the partial and give it the instructions we get from here. So this is from the output Pydantic parser. Then our class has this classification classify email function, takes our email and we check if it's more than 500, invoking the chain that we just set up. And based on this, it will the LLM will return a result that will contain a category and confidence. So we are providing the email subject and the message, that's the body, the email body that we get. Then we return this category and result. And then there is this fallback classification that we got from the Pydantic output parser, and here we are using individual keywords to track which one we got, and then based on that we either return order request or the product inquiry. Then we have this classify batch to get a list of emails and process them all at once, and this is the actual function that will be used. In this function, what we are doing is we are creating a results array that is going to track email and products list, and we go through all these emails one by one, and we call the classify email function that returns us the category and the confidence that we just saw above. We get the category and confidence. We create this email classification, which needs an email ID and the category that we just processed, like is it order request or is it a product inquiry. So for each email we are creating this, and then we are adding it to the result, and based on the confidence we are just printing out some stuff that says high confidence or low confidence. In Gemini models, because they have a rate limit, and based on this rate limit your application can stop midway, so we have to respect the rate limit. And for that we have added here the time.sleep to wait for maybe 1 minute or whatever works for you, and then continue on to making the next request to the model. Based on this, we have some results, and this is for the Cohere model. We provide the Cohere LLM that we defined above into the email classifier and create an instance of our class, and from this class we call the classify badge function on our validated emails that we got. What we do is we just print the results, and remember we are just tracking them. And similarly we track the Gemini performance, and we store the results, and here we are getting all the categories for the email IDs, and this is where we are just showing some of the results, and this is for the Cohere. And we are creating a data frame from the classifications that we got. We can do it this way. We are then reading the result.json. So this file is actually what you can say the source of truth. Here we have already created this list. It is the actual result. That means this email is actually of order request, and this email is actually of order request, and so on. Getting this into our program so that we can then set what results and what kind of performance we got from both the models. Here we are just displaying few of the validation data that we get from result.json. Do some data analysis on the performance of both the models. So we are creating a dictionary for both the models here. This is the Gemini model and this is the Cohere model. What the Gemini model is we get the total number of emails that it processed, and we get the correct results that it got. We compare them with the ones that we already have, like this is the source of truth that we just showed, and we compare each one that the Gemini model predicted that this can be order request or product inquiry, and we compare it with our validation set, and then we sum it up. So this is the total number of correct predictions Gemini made, and then we are storing the accuracy here. This is the percentage of correct predictions Gemini made, and similarly this for the Cohere one, and we create a data frame from these metrics for both. So Gemini tried on 30 and correctly predicted 19, and it is 0.633 or 63% accuracy, and Cohere has 60%. So Gemini is performing slightly better. And then we just plot their performances using Matplotlib, and just for displaying and having a nice figure out of this. And this is the whole task that we were set out to do, and this will actually be in the available in a GitHub repository, and I will share the link in the description. So coming on to what we will be going to do next is we will extract the order details from emails. Right here we got all these classifications. We classified all these emails into order request and product inquiry. So building upon this, what we will do is for all the order requests, we will extract the order details from the emails, what kind of product the customer has requested and what amount he wants, and then we will extract this data, and we will check if the requested quantity is present in our inventory or we are out of stock, and then we will generate some response emails based on this result. And let's see you then. Don't forget to subscribe. So we will be building a lot more on this, and just stay tuned, like the video. Thanks for watching. Bye.